So when you're adding and subtracting rational expressions, you find the LCD first. You rewrite the rational expression as an equivalent expression with that denominator. You add or subtract, and then if necessary, you want to simplify the result. So this one right here. Can we factor these denominators? No, we can't. They're already factored. So what would my LCD be? My LCD would be x plus 1 times x minus 1. So I'm going to rewrite these fractions with x plus 1 times x minus 1 at the bottom. That's my new LCD. What did I multiply this first one by to get from here to here? Well, I multiplied it by an x minus 1. So whatever you do to the bottom, you got to do the same thing to the top. So this is going to become 3 times x minus 1. What did I do to get from here to here? Well, I multiplied it by x plus 1. So I need to do the same thing to the top. This is 4 times x plus 1. So now, keep in mind, I don't want to cancel these. I'm trying to put these together. So what I'm going to do is I'm going to distribute here, which is going to be 3x minus 3. Plus, I'm going to distribute on this side, which is going to be 4x plus 4, all over x plus 1 times x minus 1. Let's simplify this a little further. 4x plus 3x is going to give me 7x. Negative 3 plus 4 is going to give me plus 1, all over x plus 1, x minus 1. Now, can I simplify this? Can I factor anything? Can I cross out anything? No, I can't. So that's going to be my final answer. Let's look at another example. Again, your first step is going to be to factor your denominators. So that's what I'm going to do here. Minus, this is 4. This is going to be x minus 8, x plus 1. So what is my LCD? Let's write down my first denominator, x plus 5, x minus 1. Anything new over here? Yes, x minus 8. So I'm going to rewrite both of these fractions with a denominator of x plus 5, x plus 1, x minus 8. X plus 5, x plus 1, x minus 8. So what is being multiplied to go from here to here? Well, you're multiplying by an x minus 8. So I need to do the same thing to the top. This is going to be 3x, x minus 8. What is being multiplied to go from here to here? You're multiplying by an x plus 5. So I'm going to do the same thing to the top here. So this is going to be negative 4 times x plus 5. Let's put this all together. Your goal is to put it together into one big fraction. I can distribute here, which is going to give me 3x squared, and this is going to be minus 24x. Here's where you're going to have to definitely be careful. I told you subtraction, that's when you want to put a star beside, do whatever you need to do. Just to remind you that I'm not just distributing 4, I'm distributing negative 4. So this is going to be minus 4x, and this is going to be a minus 20. Not a plus 20, minus 20. So let's rewrite this. This is going to be 3x squared. This is going to be minus 28x. And this is going to be minus 20 all over x plus 5, x plus 1, and then x minus 8. Now you do want to check to make sure that this cannot be simplified any further, meaning can you factor your numerator and then cancel something out here? I will tell you for the sake of time that this does not reduce down. You cannot simplify anything out with your denominator, so this one would be finished. I want you to try 2 examples on your own. When you're ready, hit play to check your answer. All right, so let's see how this went. So in the first one, you can't factor your denominators, but you can write them as your LCD. So your first denominator is 2x plus 3, and your second is x minus 1. So that would be your new common denominator, 2x plus 3 times x minus 1. 2x plus 3, 3, and then x minus 1. What did I multiply by? I multiplied by x minus 1 here, so I'm going to do the same at the top. This is 5 times x minus 1. I multiplied here by 2x plus 3, so this is going to be multiplied by, so again, I multiplied by 2x plus 3 here. I'm going to do the same at the top. Remember, your goal is to condense these down into one fraction So my first one, I'm going to distribute that 5 and make it 5x minus 5. The second one, I'm going to distribute that 7 and make it 14x, and this is plus 21. Can I simplify this down a little further? Sure, I can add 14x and 5x, which is 19x. Negative 5 plus 21 is going to give me a positive 16, all over 2x plus 3, and then x minus 1. And that cannot be simplified down any further. I'm going to rewrite this first fraction with a factor denominator of, this is going to be, excuse me, let me erase this. This is going to be p minus 2. Try that again. So this is going to be p minus 2 and then p minus 1. Minus 2 over, this is a difference of squares, so this is going to be p plus 1 and then p minus 1. So what would my LCD be? It would be my first denominator, which is p minus 2, p minus 1. Anything new in the second denominator is going to be p plus 1. So I'm going to rewrite that in my denominator for both of them, p minus 2, p minus 1, p plus 1. Minus, we're going to do, again, p minus 2, p minus 1, p plus 1. I can multiply this first denominator by p plus 1, which is going to multiply this guy by p plus 1 as well. So this is going to be 3 times p plus 1. I'm going to multiply this one here by a p minus 2. So I'm going to multiply this one by p minus 2 as well. So this is going to be 2 times p minus 2. All right, so now I'm going to rewrite that denominator one more time. P minus 2, p minus 1, p plus 1. If I multiply that 3 out, that's going to be 3p plus 3. I'm going to be very careful right here, and I'm going to distribute a negative 2. So that's going to give me negative 2p, and then negative 2 times negative 2 is plus 4. Now I can rewrite this as 3p minus 2p is just p. 3 plus 4 is going to give me 7, all over p minus 2, p minus 1, and then p plus 1. So that's my final answer. All right, next topic is complex fractions. So, man, fractions within a fraction. And so it's essentially when either your numerator or your denominator of your fraction contains a fraction. So our goal with these is actually going to be to clear out the fractions just to make our lives a little bit easier. What we do to simplify complex fractions is that we come up with the LCD of the fractions that appear in our problem. So 2 over x is a fraction, x over 5 is a fraction. So my LCD would be essentially rewriting these two denominators together as 5 times x or 5x. Now to clear out fractions, what you do is you multiply every piece of this problem by 5x. So this guy gets multiplied by 5x, this guy gets multiplied by 5x, you down here gets multiplied by 5x, and then this one gets multiplied by 5x too. Whenever you multiply a fraction by a common denominator, what essentially happens is the piece of this common denominator that's in common here, so the x's are going to cancel each other. So x's are gone. So you're left with 5 times 2, which is 10. Now this is just x times 5x. So x times 5x is 5x squared. What cancels with this fraction would be the 5, so they're gone. X times x gives me x squared. X times 5x gives me 5x squared. Now you do want to see if this can be simplified, so you can factor. You could take out a 5 here, which would leave you with 2 plus x squared. You could take out down here at the bottom, you could take out an x squared. Actually, you can actually combine these two together. X squared plus 5x squared gives you 6x squared. So notice by doing this though, it really didn't help me in terms of being able to cancel anything. So this would just be my final answer. So look at another example of this. We got to come up with that least common denominator. So let me write down my first denominator, which is x minus 1. This fraction has a 2 in the denominator, so that's going to need to be included. Now I don't need another x minus 1. It already appears here, so this is my least common denominator. So every little piece of this fraction gets multiplied by that common denominator. So this one down here gets multiplied by 2 times x minus 1. The reason you do this is when you take that LCD and multiply it by everything here, pieces of your fraction in the denominator will cancel. X minus 1's cancel, which leave you 2 times 4, which is 8. The 2's will cancel here. So what this leaves you with is x minus 1 times x minus 1. So we are going to have to multiply this out. X minus 1 times x minus 1. X times x is x squared. X times negative 1 is negative 1x. Negative 1 times x is negative 1x. Negative 1 times negative 1 is a positive 1. So this is x squared minus 2x plus 1. Now I've got to be careful because this whole thing, subtraction, you got to be very careful with subtraction. So when you multiply these two out and you get this trinomial, that subtraction gets distributed to everything in that trinomial. So this is going to be minus x squared. Negative times negative gives you a positive 2x. Negative times positive 1 gives you minus 1. All over. Now the x minus 1's cancel here. So 2 times x plus 2 would be 2x. And then 2 times 2 would give you 4. So let's rewrite this. This is negative x squared plus 2x. 8 minus 1 is going to give you 7. All over 2x plus 4. And that would be your final answer because you can't factor anything, so this would be it. So the process that we're using to simplify complex fractions can also be used to solve rational equations. So everything we've been dealing with up to this point has not had an equal sign. We're about to get into some problems that actually have an equal sign. So we're going to get an answer. We're going to actually solve them. How are we going to solve equations with unlike denominators? We're going to basically do that same process that we just used with complex fractions. You are going to come up with your common denominator. You're going to multiply each fraction by the common denominator to get rid of the fractions. You're going to simplify and then you're going to solve. Now, if your solution makes the denominator equal to 0, then it's not actually a solution to the equation. Sometimes you have done all the work correctly, everything's wonderful, but when you solve it, you get an answer that makes the denominator equal to 0. So unfortunately, that's not going to work. So your answer would then be no solution. Let's look at this example here. What is my LCD? So what is a number that both 3, 5, and 6 would go into? Off the top of my head, 30 would work. So I'm going to multiply every piece of this equation by 30. Now, when you're multiplying numbers by a fraction, what you can do is you can cancel these, but 30 divided by 3 gives me 10. So 10 times 2x gives me 20x. So notice what happens here. 30 divided by 5 gives me 6. 6 times x plus 2 gives me 6x minus 12. And then 30 over 6 cancels to give you 5, but then 5 times 1 gives you 5. So now you can just solve it. This is 26x minus 12 equals 5. We'll add 12 to both sides. Oh, that looks like a 72. That's 12, by the way. 26x is equal to 17. Divide by 26. X is equal to 17 over 26. So the nice thing about equations is that you will get a number answer. Let's look at another one. Now, to determine the least common denominator, everything needs to be factored. These are factored, but remember, this one factors as a difference of squares. So I'm going to write it right underneath. So what would my LCD be? My LCD would be x plus 2 times x minus 2. I'm going to multiply every piece of the equation by x plus 2, x minus 2. X plus 2, x minus 2. Let's cancel some denominators. So those are gone. 4 times x minus 2 gives you 4x minus 8. Cancel these. 5 times x plus 2 gives you 5x plus 10. And then all of that cancels just to give you 29. So this is going to be 9x and then plus 2 is equal to 29. We're going to subtract 2. So 9x is equal to 27. Divide by 9. X is equal to 3. Now, does 3 cause any of the denominators to be equal to 0? No, it doesn't. So that is a solution to this equation. Let's look at one more.